Untitled. So today we're going to look at coordinate geometry. Now the first thing that we need to be familiar with is the word Cartesian plane. So if I said what is a Cartesian plane, would anyone have any idea what that is? Yes?
If I'm remembering correctly, it's like an X and Z, I think it's two lines.
Yeah, so basically it's two number lines which intersect each other. There's a vertical number line which comes across here. Sorry, a horizontal. And then we've got a vertical number line that comes across here. Now, like you said, we can use different letters to describe the two number lines. So the horizontal one is the X, and the vertical one is called Y. So it's basically a graph. We did some graphing in science already this year. Now, basically each number line, as we've been practicing, will have equal increments along here, and equal increments along here, and equal increments along here, and equal increments along here. Now, the x-axis, so we can call these number line axes. So this is the x-axis, and this is the y-axis. Now, the scale of the x may be different to the scale of the y. What do I mean like this? By that, the x could go up in increments 1, so that might be 1, 2, 3, 4, 5, 6, 7, so on. And the y might go up in 5, 10, 15, 20s, or it might go up in 2, 4, 6, 8. The x and y don't necessarily need to go up in the same increments, but all the numbers on the x need to go up in the same increment, and all the numbers in the y need to go up in the same increments. So, why is this useful? Because we can basically, like we have already done in science, we can plot data points on a graph, and it can be a nice, easy visual way to look at some data. So, I'm going to add some numbers to these axes. So this is going to be 1, 2, 3, 4, and then on this side of the number line, if this is 0 there, what would that value there be?
-1.
Good, so we have -1, -2, -3, -4. And this side of the y is going to be our positive numbers, so 1, 2, 3, 4, and -1, -2, -3, -4. Now, the point in the middle, where I've drawn that circle, that has a special name. We call that the origin. So this here is called the origin. Now, you can just listen for now, you can copy it in your book after. Now, we can plot points on this Cartesian plane. So if I was to plot a point here, now it's a lot easier when you've got graph paper to do this because you can see where the lines intersect each other, but I've only got normal paper. So if I wanted to label, you know what, just to make this a little clearer, I'm not going to choose the point 33 for a specific reason. I'll go to the point 3, 1. So, if I was to plot a point there, we can describe that point's location on the Cartesian plane with a set of coordinates. So, it's on the x-axis, 3 spots to the right, comma, and on the y-axis, 1 spot up. So when we're describing the position of these coordinates, we always put the x position first, and we always put the y position second. So the reason why I didn't do 3, 3 is because you don't know which one I'm putting first and which one I'm putting second. So if I was to go here, so I come 4 across and 3 up, what could I describe my coordinate for that to be? Yep.
4, 3.
Good. 4, 3. So that's a way of describing points on a Cartesian plane. Now the origin, I said, is at that point there. What would the coordinates of the origin be? Lincoln? 0, 0. Good. Like I said, in a minute I'll get you to copy that. There's just one more thing I want to show you first before you copy it. Actually, I won't draw it again, I'll just do it on this one. Now, you can see that there's 4 different sections on these graphs. Now those sections, 1, 2, 3, 4, have special names. We call them quadrants. So this area here is quadrant 1. This area here is called quadrant 2. This area here is called quadrant 3. And this area here is called quadrant 4. So if we focus on quadrant 1 for a second, all the x values are positive or negative? Positive, and all the y values are? So in quadrant 1, this quadrant here, all the x values are positive, all the y values are? Positive. So if I was to plot any point in here, both of those numbers would be positive. If I look at quadrant 2, our x values are all going to be negative, and our y values are going to be. So all of our x values in here will be negative, and all of our y values will be positive. So I might plot a point here, so 3 across, 1 up. What would be my coordinates of that?
-3, so -3, on the 1.
Good. Alright, and see how he's described the x position first, the y position second. Whatever point you plot in that quadrant, the x will always be negative, the y will always be positive. Alright, quadrant 3. All my x values are, and all my y values are. So any point that we plot in here is going to have 2 negatives. So if I came 2 across and 4 down, what would be the coordinates of that point there? Ben?
-2, -4.
Good. -2, -4. Notice that both values are negative. And then finally in quadrant 4, you can see the x values are all positive, y values are all negative. So if I came 4 across, 3 down, what would be my value of that point there? Someone different? Yep.
4,
Yep.
-3.
Good. Alright, so we're going to play a game of battleship, coordinate geometry battleships. So basically each player gets a sheet. Now there's 4 types of boats. We got the battleship, the submarine, the destroyer, and the patrol boat. Now one of these graphs is for your shots, one of them's for your ships and your opponent's shots. So you need to draw these 4 types of boats somewhere on this Cartesian plane. So for example, my battleship, it needs to be 5 things long. Now let's just play verticals and horizontals, no diagonals. So my battleship, I might put it 1, 2, 3, 4, 5. And then I can put a rectangle around it to signify that that's my battleship. Then I have to do the same for my destroyer. So I might go 1, 2, 3, 4 here. There's my destroyer. Then I might go, my submarine is here. 1, 2, 3. And then my patrol boat might go 1, 2. Alright, so once you and your opponent have both set out your ships, then you need to take turns at trying to hit each other's ships. So I might be playing Brendan, and he might take a guess. Now he has to take a guess by saying the coordinates. So Brendan, say this coordinate here. What is that one?
3, -2.
Negative or positive?
Oh, positive.
So 3, 2.
Yep, right.
Alright, now, in reality, he can't actually see my thing, but just so I can explain the game, he says 3, 2. I say, yep, you've hit my ship. He gets another go. Then he says 5, 1. Or sorry, he says 5, 2. I say, nope, you've missed my boat. I'll put in his shot there, just so then I can remember that he's already had a shot there. On his sheet, he needs to be recording where he's taken his shots. Why would he be recording where he's done his shots?
So he doesn't go to the same spot?
So he doesn't do the same spot. Alright? Is everyone clear on the rules of that game? Yep. Yep, but do dots. Now this is important. The dots have to go on the intersection of of the grids. You can't put them in the middle of the boxes. If you go in the middle of the boxes, that would introduce fractions. Alright, see how my dots are all on the intersections of the boxes? That's how yours have to be. All right, any other questions?